Bismillahirrahmanirrahim. Dear students, let's start with the second part of the tutorial. In the second part, basically, we are going to discuss that if any given continuous time signal or discrete time signal is basically a power signal or energy signal. For that, what we are going to do basically, we will be calculating the energy and power, and based on that one, we will decide if a given signal is energy signal or power signal. We say that for the energy signal, we should have we should have a finite energy of that particular signal. Okay, and for the energy signal, if my energy is finite, I should have a zero power to make it an energy signal here. The second one is about the power signal. If I want my signal to be a power signal, then we will say that the signal has the finite power and its energy is basically infinite. Okay, so if a signal does not satisfy these two categories or these two conditions, then we will say that the signal is neither energy signal and nor power signal. Okay, so let's start solving few examples here. Okay, so our first example is, I am not going to solve all the example, but I will solve some of them. Okay, so the remaining are basically your practice question and you can try them in the home here. So the first one is basically, let's suppose we say that we are given a signal x of t here. We are given a signal x of t, which is basically 2t squared here. So basically what we want here, we want to check if this given signal is energy signal or power signal. So as I told you before, that first of all, we will always try to calculate its energy. Okay, and then power here. So let's suppose the energy, you know the formula already, you should have studied. So energy will be equal to, we said that the integration from minus infinity up till the positive infinity, my signal x of t mod square dt here. Now you can see I have put the sign of, you can say like this is the mod sign or this is the magnitude sign, and it will come into play when my signal is a complex signal. Means it has basically the complex part, or you can say the imaginary part. Then in that case, we are going to calculate the magnitude and then we take the square and we integrate. Okay, so in this case it's quite straightforward that this is not a complex signal, so it means if my signal is 2t square, then I need to only take the square of it. So it means it will be like the integration from minus infinity up till the positive infinity. We have 2t square, and it's only the square in this case. Okay, and it's equal to dt here. And the next thing is basically uh, we need to solve it, so it means this will become equal to integration from minus infinity to infinity, so it will become 4t power 4 dt here. Now it's a straightforward integration here. Okay, we will take 4 outside the integration here, and the integration of t power 4 is basically t power 5 divided by 5. So what we will get here, we will get basically, like I'm taking it outside, so it will be like 4, and I will get the t power 5 divided by 5, and my integration is going to be between minus infinity to infinity. So basically when you substitute the infinity in t, means variable here is t, so it means like infinity minus infinity will give me the infinity. Okay, so it means I got an infinite energy in this case here, energy. Clear? So since the energy is infinite, so let's check for the power here. So if energy is infinite, and I have two options here. Either my power will also become infinite. So if my power also become infinite, in that case my signal is going to be a neither signal. Okay, neither energy nor power. Or the second possibility is my power of a signal becomes 0. Sorry, it has like some value. It becomes finite value. So in that case, we will say that this is a power signal here. Okay, so the power formula is limit t tends to infinity here, and 1 divided by 2t. 1 divided by 2t, we have the integration from minus t up till positive t here, and again it should, let me write it, no problem, x of t. I'm just writing the formula this time, and for the next question I will do it directly. Okay, so please memorize this formula here. So now if you see here basically our signal was 2t here as we calculated earlier, and when we did the integration or when we did the simplification, means we put the value in x of t here, then what we got basically, we got 4t power 4 here, and then the integration was 4t power 4 by 5 here. Okay, so basically I will get the same thing. The only changes we are not going to, we have the limits are going to be changed in that case. So basically what we will get here, so I'm just writing it directly here, I will get limit t tends to infinity here. Okay, we are going to have 1 divided by 2t, and from the other one, since I have 4 here, I told you I will get 4. Let me write 4 here so you know, like I'm taking it from the above. It will be like t power 5 divided by 5, and my limit is going to be minus t and capital T here. Okay, so basically what we have is exactly, it is basically exactly, so I'm just moving it up a little bit. Now if you further simplify it, we will get basically limit and t tends to infinity here, and it will be 1 divided by 2t, or maybe like it's become 2 divided by t, 2 divided by t here, and even 5t basically, because 5 is also here, and it will become capital T power 5 minus t power 5 here. Okay, so this is what we are going to get here. So minus minus will become plus here, so it means it will become limit t tends to infinity here. I will get 2 divided by 5t here, and we are going to have 2t power 5 here. So if I divide them, basically like if I divide t with this one, so it will become 2t power 4 here. Okay, so basically I still have the t in the numerator, and when we apply the limit here, so it means uh, it will give me infinity in here basically. So basically what happened, we also got the power as infinite here. Okay, so power is also infinite here. So in this case we said that the given signal is neither energy and nor power signal here. Okay, so I think it is quite clear now. Okay, thank you.